Right now, at this very moment, creatures are living in total darkness at the bottom of the ocean that no human being has ever laid eyes on. Underwater lakes sit on the seafloor, so toxic that anything swimming into them drops dead instantly. Sounds have echoed through the deep that scientists spent years trying to explain, and there is a point on the floor of the Pacific Ocean so deep that Mount Everest could be dropped into it, and the summit would still sit more than a mile beneath the surface. The deep ocean is the last great frontier on Earth, and what we have found down there is stranger than anything we ever imagined. This is the story of the strangest things we have ever discovered in the deep. We like to think we know our own planet. Every continent has been mapped. Every major city has been photographed from space. Footprints sit on the moon, and robots have driven across the surface of Mars. But right here on Earth, right beneath the waves, there is a world we have barely touched. Roughly 70% of this planet's surface is covered by ocean. Its average depth exceeds 12,000 feet, and according to the National Oceanic and Atmospheric Administration, more than 90% of that ocean qualifies as deep sea, meaning it sits below 656 feet, where sunlight fades and eventually disappears altogether. So how much of this enormous space have we actually explored? As of June of 2024, NOAA reported that roughly 26% of the global seafloor had been mapped using modern high-resolution sonar, and that sounds like progress. But mapping with sonar is not the same thing as actually seeing what is down there. In May of 2025, a study published in the journal Nature put a much more sobering number on it. Oceanographer Catherine Bell and her collaborators calculated that scientists have visually observed less than 1,000% of the deep ocean seafloor, an area roughly the size of Rhode Island, out of a seafloor that stretches across 360 million square kilometers. We have laid eyes on a fraction so small it barely registers. We have better maps of the surface of Mars than we do of the bottom of our own ocean. And that number becomes even more staggering when you consider this. The National Oceanic and Atmospheric Administration estimates there may be between 700,000 and 1 million species living in the ocean, and roughly 2/3 of them have not yet been discovered or officially described. Nearly 2,000 new marine species are accepted by scientists every single year, and the list keeps growing. In 2022 alone, a single expedition off the coast of Chile brought back more than 100 new species from the deep Pacific, and in 2025, researchers in the Southern Ocean near Antarctica discovered more than 30 species previously unknown to science. NOAA fisheries zoologist Mike Vecchione once put it this way: "Of all the space on Earth that contains multicellular life, more than 95% of it sits in the deep sea, and we know almost nothing about it." The famous oceanographer Robert Ballard, the man who discovered the Titanic, made the comparison even more bluntly. He said that NASA's entire annual budget to explore the heavens, taken in a single year, would be enough to finance NOAA's ocean exploration budget for 1,600 years. We have poured our resources into looking up, and the greatest mysteries on this planet are sitting right below us, in the cold, dark water. That is exactly where our story begins. The modern science of oceanography did not begin in a laboratory. It began on a wooden warship that set sail from England in the winter of 1872. On December the 7th of that year, HMS Challenger departed from Sheerness on the coast of Kent. She was a Royal Navy corvette, a small warship displacing just over 2,300 tons, and she had been converted for a purpose no naval vessel had ever been assigned before. Her guns had been pulled out and replaced with laboratories, microscopes, specimen jars, miles of rope, and every piece of scientific equipment the British government could provide. Her mission was simple in concept and staggering in ambition: explore the deep ocean on a global scale, for the first time in human history. A joint effort between the British Admiralty and the Royal Society, the expedition cost the British government £200,000, which in modern terms would translate to roughly £10 million. 237 men sailed aboard the ship, including 6 dedicated scientists. Sir Charles Wyville Thomson served as chief scientist, a Scottish naturalist who had already conducted preliminary deep-sea dredging expeditions in the North Atlantic aboard HMS Lightning in 1868 and HMS Porcupine in 1869. Those earlier voyages had brought up living organisms from depths well below what the azoic hypothesis said was possible. And it was those tantalizing results that convinced the Royal Society to fund a global expedition. Thomson's colleague, Sir John Murray, a Scottish oceanographer born in Canada, would later take over the monumental task of compiling the expedition's findings after Thomson died in 1882. Captain George Strong Nares commanded the vessel, an experienced Royal Navy officer who had already led Arctic expeditions. He was pulled away partway through the voyage when the Admiralty reassigned him to yet another Arctic mission, and Captain Frank Toole Thompson, no relation to the chief scientist, took over for the remainder of the journey. Daily life aboard HMS Challenger was exhausting and repetitive. At each station, the crew stopped the ship, lowered thermometers to measure water temperature at multiple depths, collected water samples in specially designed bottles, and then sent dredges and trawls down on miles of rope to scrape the ocean bottom. A single deep-sea sounding could take hours, and hauling a trawl up from 3 or 4 miles down was back-breaking work that could consume an entire day. Sailors who had signed on expecting naval service found the scientific work monotonous and frustrating. Morale dropped, and desertions increased at every port. But the scientists were in a state of constant astonishment, because almost every time the dredge came back up, it contained something no one had ever seen before. The Royal Society had laid out ambitious goals. They wanted to investigate the physical conditions of the deep sea, determine the chemical composition of seawater at various depths, examine what the seafloor was actually made of, and find out whether anything lived down there at all. That last question may seem obvious now, but in the 1870s, a widely accepted theory called the azoic hypothesis held that the ocean below roughly 1,800 feet was a dead zone. Too cold, too dark, too pressurized, too far removed from sunlight. The prevailing scientific view held that nothing could survive down there. HMS Challenger was about to prove that wrong in spectacular fashion. Over 3.5 years, the ship covered nearly 69,000 nautical miles, roughly 130,000 kilometers, crossing the Atlantic, the Pacific, and the Southern Oceans, and even crossing the Antarctic Circle. 362 stations along the way served as stopping points to take measurements, lower dredges and trawls, collect water samples, and haul up whatever sat on the seafloor. 374 deep-sea soundings were performed. 255 observations of water temperature at varying depths were recorded. Dredges were deployed at 111 stations, and 129 trawls were completed, and what they pulled up from the deep changed everything. More than 4,700 new species of marine animals were catalogued during the voyage. Not dozens, not hundreds, but thousands of creatures that had never been recorded in any textbook, any museum, or any collection anywhere in the world. Life was not absent from the deep ocean. It was thriving in ways no one had predicted. Sea cucumbers came up from the abyssal plains. Strange worms were found burrowing in the mud at the bottom of the Atlantic. Sponges, starfish, crustaceans, and mollusks appeared at depths where no organism was supposed to exist, and from one station in the South Pacific, a single trawl brought up species so numerous that the scientists worked through the night to catalogue them all. Among their most dramatic findings was a sounding taken in the Western Pacific, in the area we now call the Mariana Trench. The Challenger team measured a depth of 26,850 feet, more than 4 miles down, the deepest point anyone had ever recorded. Modern measurements have since placed the true deepest point even greater, at roughly 35,876 feet with a margin of error of about 20 feet, and that spot is now called Challenger Deep, named in honor of this ship and its crew. The expedition also confirmed the existence of the Mid-Atlantic Ridge, an enormous underwater mountain range stretching through the Atlantic Ocean. Systematic maps of deep ocean currents and temperatures were compiled for the first time, and the crew produced the first real evidence that the ocean floor was not a featureless, lifeless plain, but a complex terrain of mountains, valleys, trenches, and plains teeming with organisms. 50 volumes of results were published between 1880 and 1895, compiled by John Murray after Thomson's death, and those 50 volumes laid the foundation for the science of oceanography. When the ship returned to Spithead, Hampshire, on May the 24th, 1876, only 144 of the original 216 crew members remained aboard. 7 had died during the voyage, 26 had been left behind at hospitals or could not continue, and several had deserted at various ports of call. It had been grueling, but the Challenger expedition proved that the deep ocean was a world worth exploring, and it was the beginning of everything that followed. For decades after the Challenger returned, the deep sea remained a place that could only be studied from the surface. Scientists lowered dredges and trawls, dropped weighted lines to measure depth, and pulled up specimens to study in jars. No human being had ever looked out a window and actually seen the deep ocean with their own eyes. That changed on a summer day off the coast of Bermuda in 1930. William Beebe was an American naturalist, a best-selling author, and one of the most famous scientists of his time. His friend Otis Barton was an engineer who had designed a radical new vessel, a hollow steel sphere just 4 feet and 9 inches across, with walls 1.25 inches thick and 3 small windows made of fused quartz. It weighed 5,000 pounds, had no motor, no propulsion system, and no way to move on its own. It was simply lowered into the ocean on a single steel cable and pulled back up again. They called it the bathysphere. On June the 11th, 1930, Beebe and Barton climbed inside. The hatch was bolted shut from the outside, and a crane lowered them over the side of a research vessel into the Atlantic Ocean. That first descent took them to 803 feet, deeper than any human being had ever gone. Over the next 4 years, they went deeper and deeper. A telephone cable ran alongside the steel tether, and Beebe narrated everything he saw to his colleague Gloria Hollister on the surface, who copied down every word. In 1932, NBC actually broadcast his voice live from the deep, the first radio transmission from beneath the sea. August the 15th, 1934, brought their most famous dive. Beebe and Barton descended to 3,028 feet, more than half a mile down, a world record that stood for 15 years. Through the tiny quartz windows, Beebe described a world that sounded like science fiction. Fish glowed in the dark, some producing patterns of light that looked like constellations. Creatures so bizarre he could not match them to any known species drifted past the glass. He wrote later that what he witnessed seemed to belong to another planet entirely. The bathysphere never dove again after 1934, but Beebe and Barton had proved something that changed the trajectory of ocean science. The deep was not just a place you could measure from the surface. It was a place you could go and see with your own eyes. And it raised an obvious question. If the deep sea was this strange at half a mile down, what would be waiting at the bottom? For 84 years after the Challenger expedition mapped the general location of the deepest point in the ocean, no human being had gone down to see it. The bathysphere had gotten humans to half a mile, But the deepest point on Earth sat nearly 7 miles down. The technology simply did not exist. Crushing pressure at the bottom of the Mariana Trench exceeds 1,000 times the atmospheric pressure at sea level, and at that depth, every square inch of surface area carries roughly 8 tons of water pressing down on it. Building a vessel that could withstand that pressure and still carry a living human being to the bottom ranked among the great engineering challenges of the 20th century. But in 1960, 2 men decided to try. On January the 23rd, 1960, Swiss oceanographer Jacques Piccard and United States Navy Lieutenant Don Walsh climbed into the bathyscaphe Trieste and descended into Challenger Deep. The Trieste was not a submarine in any traditional sense. It was a deep-sea diving vessel, originally designed by Jacques Piccard and his father, the physicist Auguste Piccard, who had also set the record for the highest altitude balloon flight in the early 1930s. The Piccard family, remarkably enough, held records for both the highest and lowest points any human being had reached. The United States Navy purchased the Trieste from the Piccards in 1958 and assigned it to Project Nekton, a classified program to reach the bottom of the ocean. The vessel's crew compartment was a spherical pressure sphere just 7 feet across, with steel walls 5 inches thick, built by the Krupp Steel Works of Essen, Germany. That sphere was attached beneath a large flotation tank filled with gasoline, which is lighter than water and resists compression, making it ideal for deep-sea buoyancy. 9 tons of iron shot served as ballast, held in place by electromagnets. And to ascend, you release the magnets and drop the iron. There was no backup plan and no rescue system. If anything went wrong at the bottom of the Mariana Trench, no technology on the planet could reach them. The descent took nearly 5 hours. As they dropped deeper and deeper into the trench, the temperature inside the sphere fell and condensation formed on the walls. The only sounds were the creaking of the hull and the pinging of the sonar. At around 30,000 feet, one of the plexiglass exterior windows cracked, and Piccard and Walsh heard the sharp sound reverberate through the tiny sphere. The entire vessel shuddered. They looked at each other and checked the instruments. The inner sphere appeared to be holding. They kept going. When they finally reached the bottom, their depth gauge read 10,916 meters, roughly 35,814 feet. They had reached the deepest known point on Earth. Barely 20 minutes were spent on the seafloor. Through the small porthole, they observed a pale, flat expanse of sediment. And then they began the 3-hour and 15-minute ascent back to the surface. Their achievement was extraordinary, but what is perhaps even more extraordinary is what happened next, or rather, what did not happen. Nobody went back. For 52 years, not a single human being returned to the bottom of Challenger Deep. That changed in 2012, when filmmaker and explorer James Cameron piloted a submersible called the Deep Sea Challenger to the bottom alone. Cameron, who directed both Titanic and Avatar, had spent 7 years working with a team of engineers to design and build the vessel. The Deep Sea Challenger was a radical departure from the Trieste, a vertical torpedo-shaped craft painted lime green, just over 24 feet tall, but only 43 inches across at the pilot's compartment. Cameron sat in that coffin-sized steel sphere with his knees pulled up to his chest, surrounded by cameras and instruments. On March the 26th, 2012, Cameron climbed in and began the descent. He reached a depth of 10,898 meters, roughly 35,756 feet, making it the first solo dive to the deepest point on the planet. Cameron spent about 3 hours on the bottom and reported landing on a very soft, almost gelatinous flat plain. He drove across it for some distance and worked his way up a slope, and the entire time he saw no fish. No living creatures more than an inch long appeared anywhere. The only free-swimming organisms he observed were small amphipods, tiny shrimp-like creatures that scavenge on the deep ocean floor. He later described the bottom as desolate and alien-looking, a place that could be the surface of another planet. Then, in 2019, American explorer and retired Navy commander Victor Vescovo took things even further. Vescovo descended into Challenger Deep aboard the DSV Limiting Factor, a Triton 36,000 halves model, submersible designed and built by Triton Submarines in Sebastian, Florida. It was the first commercially certified submersible rated to full ocean depth, meaning it could theoretically reach any point on the seafloor anywhere in the world. Unlike the Strangest, which amounted to a one-way trip down and a one-way trip back up, the Limiting Factor could be piloted horizontally along the bottom. It had thrusters, high-definition cameras, and mechanical arms for collecting samples, and unlike every previous vehicle that had visited Challenger Deep, it was designed to go back again. Vescovo's expedition carried the name 5 Deeps, and the goal was to reach the deepest point in every one of the 5 oceans. He had already reached the bottom of the Puerto Rico Trench in the Atlantic, the South Sandwich Trench in the Southern Ocean, and the Java Trench in the Indian Ocean. The Mariana Trench was the crown jewel. On April the 28th, 2019, Vescovo reached a depth of 10,928 meters, 35,853 feet, 16 meters deeper than any human had gone before, roughly 52 feet. He spent 4 hours on the bottom, longer than Pickard and Walsh and Cameron combined. What he found down there was sobering. Along with new species of amphipods and translucent deep-sea organisms, Vescovo filmed something that had no business being at the bottom of the ocean. Sitting on the sediment, nearly 7 miles below the surface, was a plastic bag, and beside it lay several candy or food wrappers. Human trash at the deepest point on the planet. Later dives confirmed the finding. Chinese expeditions in 2020 and 2021 retrieved samples from the trench containing microplastic fibers, and laboratory analysis of amphipods collected from Challenger Deep revealed traces of persistent organic pollutants in their bodies, chemicals that had been banned decades earlier. Because the water at that depth moves so slowly, researchers believe that whatever makes it down there could remain for thousands of years. Between April of 2019 and July of 2022, 20 crewed visits were made to Challenger Deep using the Limiting Factor. Vescovo himself completed 15 descents, a record that speaks to just how reliable the vessel was. Among the other visitors was Kelly Walsh, the son of Don Walsh, who descended in June of 2020, exactly 60 years after his father had made the same journey in the Strangest. On June the 7th, 2020, Dr. Catherine Sullivan became the first woman to visit the deepest point on Earth. Sullivan was an oceanographer, a former NASA astronaut, and a former administrator of NOAA. In 1984, she had become the first American woman to walk in space, and by descending to Challenger Deep, she became the first person in history to have both orbited the Earth and visited its lowest point. No other human being has accomplished that combination. As of the most recent counts, 27 people have been to the bottom of Challenger Deep. Only 24 people traveled to the Moon or orbited it during the Apollo program, which means fewer people have been to the bottom of our own ocean than have left the planet entirely. Victor Vescovo, who had also summited Mount Everest in 2010, became the first person recognized by Guinness World Records as having reached both the highest and lowest points on the surface of the Earth. He climbed to 29,032 feet above sea level, and he descended to 35,853 feet below the surface of the Pacific. After one of his dives, Vescovo described a moment of peace at the very bottom of the world. He turned off his thrusters, leaned back in the cockpit, and ate a tuna fish sandwich while slowly drifting just above the sediment of the deepest place on Earth. 1,000 miles to the west, Chinese scientists were about to push even further into the unknown. In the fall of 2020, the Chinese Academy of Sciences sent the manned submersible Fenduje, which translates to Striver, into deep-sea trenches in the northwest Pacific. The vessel represented China's most advanced deep-sea submersible, capable of carrying 3 people to full ocean depth. Between October and November of that year, the Fenduje completed 13 dives in the Mariana Trench, making China one of only a handful of nations with the technology to reach the bottom of the ocean. What the scientists found on the seafloor made headlines around the world. At a depth of more than 31,000 feet, in total darkness, under crushing pressure, they discovered entire communities of living organisms. Fields of marine tubeworms dotted with white snails covered the seafloor. Centipede-like creatures crawled through the sediment, and clams nestled alongside anemones. It was not a barren wasteland. It was a neighborhood. These were not scavengers surviving on scraps falling from above. These organisms were sustained by chemosynthesis, a process in which microbes buried beneath the seafloor produce methane, and bacteria convert that methane into nutrients that support an entire food chain. No sunlight involved, no photosynthesis, just chemistry and life, thriving in a place that was once considered utterly inhospitable. The scientific team documented their findings in extraordinary detail. They used the submersible's cameras to film the communities in situ, capturing footage of organisms that had likely never been exposed to artificial light before. And they collected samples of the sediment, the water, and the organisms themselves, bringing them back to the surface for analysis. The discovery, published in the journal Nature, was the deepest community of chemosynthetic life ever found, and it challenged what scientists thought they knew about the limits of life on Earth. Researcher Mengran Du from the Chinese Academy of Sciences noted that the presence of these chemosynthetic ecosystems challenges long-standing assumptions about life's potential at extreme depths. The Mariana Trench, it turns out, is not a lifeless void. It is an ecosystem, a strange one, an extreme one, but an ecosystem all the same. Organisms down there have never encountered a single photon of sunlight in their entire existence. They live on chemistry alone, sustained by gases rising from deep within the Earth. And the discovery that life could exist this way, completely disconnected from the sun, without photosynthesis, without warmth, without light, was not made in the Mariana Trench at all. It happened 20 years earlier, 1,000 miles to the southeast, along a crack in the ocean floor near the Galapagos Islands, and it remains one of the most important biological discoveries of the 20th century. That is where we are headed next. On February the 17th, 1977, a small submersible called Alvin descended through 2.5 kilometers of black water toward the floor of the Pacific Ocean. Alvin belonged to the Woods Hole Oceanographic Institution in Massachusetts. She was one of the first deep-sea research submersibles ever built, and by 1977, she had already been in service for more than a decade. She was tiny, with a crew compartment made of a titanium sphere just 6 feet across, barely large enough for 3 people to sit inside with their knees touching. On that particular morning, Jack Donnelly sat at the controls. The 2 scientific observers were Jack Corliss, a geologist from Oregon State University, and Tjeerd van Andel, a geophysicist from Stanford. They were part of a larger expedition aboard the research vessel Noor, which had departed from the Panama Canal on February the 8th. The National Science Foundation funded the expedition, and the team included scientists from Woods Hole, Oregon State, MIT, and Stanford, among them Robert Ballard and Richard von Herzen. Their destination was a stretch of the sea floor along the Galapagos Rift, roughly 400 miles west of Ecuador and about 330 kilometers northeast of the Galapagos Islands. Scientists had suspected for years that hot water might be venting from the seafloor in this area, and temperature readings from earlier surveys had shown small but unmistakable warm spots on the ocean bottom, places where the water ran slightly warmer than the near-freezing temperatures that normally prevail at that depth. They were looking for hydrothermal vents. They expected warm water and mineral deposits. What they did not expect was what they actually found. The night before Alvin's dive, the expedition's deep-towed camera system, a steel cage called Angus that carried cameras and temperature sensors, had been dragged along the seafloor on a long cable. Sometime around midnight, the instruments recorded a sudden spike in temperature. When the film was developed the next day, the photographs taken during that temperature spike showed something astonishing. Scattered across the dark basalt seafloor were enormous white clams. Living clams, at a depth of over 8,000 feet. In total darkness, miles from the nearest ray of sunlight. Nobody could explain it. That morning, Alvin dove to investigate, dive number 713. When Donnelly, Corliss, and Van Andel reached the coordinates where the clams had been photographed, they entered what Robert Ballard would later describe as another world. Warm, shimmering water rose from cracks in the ocean floor, tinted blue by dissolved minerals. The temperature in those cracks measured roughly 16 degrees Celsius compared to the 2-degree ambient water surrounding them, and clustered around these warm fissures was an explosion of life. Giant white clams, mussels, crabs, anemones, and worms crowded together in dense communities, thriving in a place where absolutely nothing was supposed to be alive. Jack Corliss spoke into the acoustic telephone from inside Alvin. His words, transmitted up to the scientists aboard the Nor, captured the disbelief of the moment. He said something to the effect of, "Is the deep ocean not supposed to be a desert? Because there were all these animals down there." The scientists on the surface were astonished. They had come to study geology, to measure water temperatures and collect rock samples. They had not brought a single biologist on the expedition because nobody expected to find life. They had not packed enough preservatives to store biological specimens, and when they began pulling up clams and other organisms, they ran out of formaldehyde and had to resort to storing specimens in bottles of Russian vodka that someone had purchased in Panama. They dubbed the vent site Clam Bake. Over the next several days, Alvin completed additional dives, discovering 4 more vent sites, each with its own community of strange organisms. The scientists named them with the casual creativity of people who had stumbled onto something beyond their comprehension. One was called the Garden of Eden. It was the official discovery of deep-sea hydrothermal vents, and it changed biology forever. The scientists came back in 1979, and this time they brought biologists. The National Science Foundation sponsored 2 ships for the return voyage. Alvin deployed from the research vessel Lulu, while the R.V. Gillis, operated by the University of Miami, provided additional support. J. Frederick Grassel of the Woods Hole Oceanographic Institution led the expedition, assembling a team of biologists, microbiologists, and physiologists from institutions across the country. Their goal was to do what the geologists of 1977 had not been equipped to do, which was to examine how and why animals were thriving in an environment that seemed so hostile. What the biologists found at a site called Rose Garden turned out to be even more astonishing than what the geologists had witnessed 2 years earlier. Standing in dense clusters around the warm vents were enormous tube worms, snow-white stalks crowned with blood-red plumes, and some of them reached 8 feet tall. They had no mouth, no stomach, and no digestive system of any kind. When scientists cut one open, they found the interior filled with a spongy organ called a trophosome, packed with bacteria. The worms were not eating anything. The bacteria inside their bodies were converting chemicals from the vent fluid, specifically hydrogen sulfide, into organic nutrients, and the worms were being fed from within by their own internal colonies of microbes. The species received the name Riftia pachyptela. The giant white clams found on the earlier expedition were classified as Calyptogena magnifica, and they too carried symbiotic bacteria in their gills that performed the same chemical trick. Mussels did the same. Animal after animal in these vent communities had formed partnerships with bacteria that could turn toxic chemicals into food. The process sustaining them was called chemosynthesis, and it was a discovery that rewrote the rules of life on Earth. Until that moment, every known food chain on Earth depended on photosynthesis. Plants or algae captured energy from sunlight and converted it into organic matter, and everything else ate the plants or ate the things that ate the plants. The sun was the engine that powered all life, and every ecology textbook said so. But here, more than 1.5 miles below the surface, in complete darkness, an entire ecosystem operated without any dependence on the sun. The energy source was not light, but chemistry. Bacteria at the base of the food chain were using hydrogen sulfide, a toxic gas, as their fuel, oxidizing it and producing organic compounds in the process. An entire community of animals, including clams, mussels, crabs, shrimp, worms, and fish, had built their lives around those bacteria. On each of its dives, Alvin's front collection basket and cameras captured an astonishing variety of animals that had never been seen before. Unknown mussels, anemones, whelks, limpets, blind white crabs, and brittle stars appeared one after another. A delicate orange organism that looked like a dandelion turned out to be a siphonophore, a cousin of the Portuguese man-of-war. Scientists fashioned a special container to bring it to the surface, but the creature disintegrated almost immediately. J. Frederick Grassel later reflected on what they had witnessed. He wrote that it was an overwhelming experience to fly at 2,550 meters over dense beds of mussels and giant clams and stands of hundreds of tube worms crowned with blood-red plumes. The team, he described, was struck by the realization that solar energy, which powers nearly all life on the planet, was being entirely replaced by terrestrial energy, by chemical reactions deep within the Earth itself. He called it one of the major biological discoveries of the 20th century. He was not exaggerating, but the vents had another surprise in store. 2 months after the biologists visited the Galapagos Rift, in April of 1979, Alvin was sent to a completely different location. The target this time was the East Pacific Rise, at a latitude of 21 degrees north, about 1,800 miles north of the Galapagos. The expedition was a joint effort between American and French scientists, led by Fred Spiess and Ken MacDonald from the Scripps Institution of Oceanography. On Easter Sunday, April the 15th, scientists Roger Larson and Bruce Lewandijk descended in Alvin and found a hydrothermal vent field with a biological community similar to what had been found at the Galapagos. But 6 days later, on April the 21st, pilot Dudley Foster took Alvin down again, this time with observers Bill Normark and Thierry Juteau. They followed a trail of white clams across the seafloor, and then they saw something no human being had ever seen before. A tall spire of rock, roughly 6 feet high, was sticking out of the ocean floor. From the top of that spire, a jet of black fluid blasted upward into the water. Foster said it looked like smoke belching from the smokestack of a steam locomotive. They had discovered the first black smoker. The superheated fluid erupting from the chimney measured 350 degrees Celsius, 662 degrees Fahrenheit, a temperature so extreme that it melted the plastic tip of the first temperature probe the scientists tried to use. That probe was made of the same plastic used in Alvin's viewports, and the viewports had been just a few feet away from the same fluid. The black color came from dissolved metals and minerals, primarily iron sulfide, that precipitated instantly when the superheated water hit the near-freezing seawater. Over time, those precipitating minerals built up around the vent opening, forming chimney-like structures that can grow to extraordinary heights. The tallest one ever recorded was a chimney on the Juan de Fuca Ridge, off the coast of the Pacific Northwest, which scientists named Godzilla. It reached 16 stories high before it toppled over. Since their original discovery, more than 500 active hydrothermal vent fields have been found around the world, scattered along the mid-ocean ridges that snake through every ocean on the planet. And around those vents lives some of the strangest wildlife on Earth. The deep ocean is home to creatures that seem to belong more in a science fiction film than on this planet. Many of them live nowhere else. They exist in conditions of total darkness, crushing pressure, near freezing temperatures, and in some cases, water hot enough to melt lead, and their adaptations to these conditions go beyond anything found on the surface. Start with the giant tube worms already mentioned, Riftia pachyptela. They grow to lengths of over 2 meters, have no eyes, no mouth, no stomach, and no way to eat food in the traditional sense. Their entire nutritional needs are met by the symbiotic bacteria living inside their trophosome. Growth rates are remarkable for a deep-sea organism, adding more than 30 inches a year in some cases, and some researchers believe individual worms may live for more than 300 years. The anglerfish is perhaps the most iconic creature of the deep. More than 200 known species carry a bioluminescent lure, a fleshy appendage that extends from the top of their head and glows in the dark. In the pitch-black water, this glowing lure attracts prey, which swims toward the light and directly into the anglerfish's oversized jaws. But the anglerfish carries an even stranger secret. In many deep-sea species, the males are tiny, sometimes just a few centimeters long. When a male finds a female, he bites into her body and latches on, and over time his body fuses with hers. His circulatory system connects to hers, his organs dissolve, and eventually all that remains of the male is a pair of reproductive organs attached to the female's body. She may carry several males at once, fused permanently into her skin. The barrel-eye fish, also called the spookfish, has a completely transparent head. You can see straight through its skull to the tubular, bright green eyes inside, which point upward to detect the silhouettes of prey above it. The first barrel eye was described in 1939, but because every specimen had been damaged by the nets that hauled them up, scientists did not realize the head was transparent until a live one was filmed in 2004 by researchers at the Monterey Bay Aquarium Research Institute. Giant isopods are deep-sea relatives of the common pillbug you might find under a rock in your garden, except these are the size of a football. The largest specimens measure more than 10 inches long and can weigh over 3.5 pounds. They live on the abyssal plains at depths of up to 7,000 feet, scavenging on whatever dead organic matter drifts down from the surface, and they can go years without eating. The Dumbo octopus, named for the ear-like fins on the sides of its head that resemble the Disney elephant, is the deepest living octopus known to science. In 2019, researchers filming in the Mariana Trench near Indonesia recorded a Dumbo octopus at a depth of nearly 7,000 meters, more than 22,000 feet, deeper than any cephalopod has ever been observed. The frilled shark looks like it swam straight out of prehistory, with a long, eel-like body, a flattened head, and roughly 300 needle-like teeth arranged in 25 rows. It has been found at depths of more than 5,000 feet, though it occasionally comes closer to the surface. What makes the frilled shark particularly unusual is its reproductive cycle, because females carry their young for an estimated 3.5 years, one of the longest gestation periods of any vertebrate on Earth. The vampire squid lives in the oxygen minimum zone of the ocean, between 2,000 and 3,000 feet, where dissolved oxygen levels rank among the lowest found anywhere in the sea. It is not actually a squid, but the sole surviving member of its own taxonomic order. It has the largest eyes relative to its body size of any animal on the planet, and despite its menacing name, it is not a predator. It feeds on marine snow, the slow rain of dead organic particles that drifts down through the water column. And then there is the giant squid. For centuries, sailors told stories of a massive tentacled monster lurking in the deep, the Kraken of Norse legend, the monster that could drag ships beneath the waves. Scientists dismissed these stories as superstition and folklore, right up until the evidence became too large to ignore. Giant squid specimens began washing ashore or turning up in the stomachs of sperm whales, sometimes measuring over 40 feet from tentacle tip to tentacle tip. Their bodies were massive, their beaks could crack bone, and their eyes were the size of dinner plates, the largest eyes in the animal kingdom, up to 27 centimeters across, roughly 10 inches in diameter. Those enormous eyes were designed for one thing: detecting the faintest traces of light in the near-total darkness of the deep ocean. Despite the physical evidence, despite the tentacles and the beaks and the sucker scars found on the skin of sperm whales, nobody had ever seen a giant squid alive in the wild. Every specimen science had access to was dead, either washed up on a beach or pulled from a fishing net, and the living giant squid became arguably the most sought-after animal in the history of marine biology. That changed in 2004, when Japanese zoologist Tsunemi Kubodera and whale researcher Kyoichi Mori, working off the Ogasawara Islands about 600 miles south of Tokyo, managed to photograph a live giant squid at a depth of 900 meters. It was the first photographic evidence of a living giant squid in its natural habitat. The animal attacked a baited line, and the camera captured over 500 images before the squid broke free after 4 hours, leaving a 5.5-meter tentacle attached to the bait. In July of 2012, Kubodera led a joint expedition with NHK and the Discovery Channel back to the same waters off the Ogasawara Islands. Using a submersible equipped with near-infrared light, invisible to both human and squid eyes, they descended to around 630 meters. After roughly 100 dives and more than 285 hours underwater, they came face to face with a living giant squid in its natural habitat. Kubodera described the moment as stunning. He said the creature was so beautiful that he had no words to explain it. The animal they filmed measured about 3 meters long, though it was missing its 2 longest tentacles. With those tentacles intact, it would likely have measured around 8 meters. It was the first footage of a giant squid filmed alive in the deep ocean. A creature that had haunted human mythology for thousands of years had finally been seen in its own world, and the discoveries have not stopped. In 2022, a single expedition off the coast of Chile brought back more than 100 previously unknown species from the deep Pacific. In 2025, researchers exploring the Southern Ocean near Antarctica discovered more than 30 new species in waters few humans have ever visited, and that same year, a separate expedition to the Mar del Plata Canyon off the coast of Argentina documented more than 40 species new to science. Among the more recently discovered creatures is the harp sponge, found at depths of around 3,000 meters off the coast of California. Unlike almost every other sponge on Earth, this one is a carnivore, with a series of delicate vertical branches that look like the strings of a harp, each branch lined with tiny hooks that function like Velcro. Small crustaceans drifting by in the current get snagged on those hooks, and the sponge slowly digests them. The giant siphonophore is a colonial organism made up of thousands of individual animals, called zooids, each specialized for a different function. Some provide propulsion, some capture prey, some handle digestion, and some handle reproduction. The longest specimen ever recorded measured more than 40 meters, over 130 feet, making it one of the longest animals ever observed in the ocean. It is not one creature, but a city of creatures operating as a single entity. In 2023, scientists confirmed the deepest fish ever recorded. A juvenile snailfish was filmed at a depth of more than 8,230 meters in the Izu-Ogasawara Trench near Japan, more than 5 miles below the surface. The fish was translucent, ghostly white, and appeared perfectly at home in an environment that would crush most other organisms to pulp. Sea pigs, a type of sea cucumber, live on the abyssal plains at depths of 3,000 to 5,000 meters. They look like plump, translucent blobs with stubby legs, moving across the seafloor on hydraulic tube feet, vacuuming up organic particles from the mud. They are sometimes found in herds of hundreds, moving slowly across the vast flat expanses of the deep ocean floor like tiny alien cattle. The colossal squid, separate from the giant squid and in some ways even more formidable, deserves mention as well. Mesonicoteuthis. Hamiltoni is heavier than the giant squid, with a shorter but more muscular body. Its arms and tentacles are lined not just with suckers, but with sharp, rotating hooks that can swivel in their sockets. It lives in the deep waters of the Southern Ocean around Antarctica, and the first juvenile footage of a colossal squid in the wild was not captured until 2025, meaning this animal, one of the largest invertebrates on the planet, has been seen alive in its habitat only a handful of times in all of human history. The deep ocean keeps showing us that life will find a way to persist in places we once considered impossible. And perhaps nowhere is that more dramatically demonstrated than at the strangest phenomenon on the ocean floor, a place where the ocean itself forms underwater lakes. Imagine descending in a submersible through thousands of feet of open water. You reach the ocean floor, and sitting on the seafloor, you see what looks like a lake, a body of water with a clearly defined shoreline, sitting at the bottom of the ocean, with a surface, with waves. You could skim a stone across it. These are brine pools, and they are among the most bizarre and deadly environments on the planet. A brine pool is a depression on the ocean floor that is filled with water 3 to 8 times saltier than the surrounding seawater. Because this hypersaline water is so much denser than normal seawater, it does not mix. It just sits there, pooled in the depression, forming a distinct lake on the seafloor with a visible surface, a clearly defined edge, and in some cases, actual waves caused by deep ocean currents. The boundary between the brine and the normal seawater above it is so sharp you can see it with the naked eye. When remotely operated vehicles approach brine pools, they actually float on the surface of the brine, just as a boat floats on the surface of the ocean. The density difference is that extreme. These pools are completely devoid of oxygen and contain high concentrations of methane and hydrogen sulfide. They are extraordinarily toxic. Any fish, eel, or crustacean that accidentally swims into a brine pool is immediately stunned and killed by the sudden shock of the extreme salinity and lack of oxygen. Scientists who have observed these pools describe seeing the carcasses of creatures that wandered in and never came back out, littered along the edges like driftwood on a beach. Brine pools are rare, found in only 3 bodies of water on Earth: the Gulf of Mexico, the Mediterranean Sea, and the Red Sea. Even in those locations, they are few and far between, and only a few dozen have ever been discovered across all 3 regions combined. In 2020, marine geoscientist Sam Purkis from the University of Miami and his team were exploring the Gulf of Aqaba, a narrow extension of the Red Sea along the coast of Saudi Arabia, aboard the research vessel Ocean Explorer. They were using a remotely operated vehicle to survey the seafloor at a depth of 1,770 meters, more than a mile below the surface and just 2 kilometers from shore. In the last 5 minutes of a 10-hour ROV dive, they found something extraordinary. Sitting on the floor of the Gulf of Aqaba was a complex of brine pools, one large pool covering roughly 10,000 square meters, about 2.5 acres. and 3 smaller pools of less than 10 square meters each. They named them the Neon Brine Pools. The discovery was published in the journal Communications, Earth and Environment, a Nature Portfolio journal, on June the 27th, 2022. And what made these pools particularly notable was their proximity to shore and the fact that they were the first brine pools ever found in the Gulf of Aqaba, extending the known range of these formations. But the truly extraordinary finding was buried in the sediment beneath the pools. Because the brine water contains no oxygen, nothing can burrow through the sediment below it, meaning no worms, no shrimp, no organisms churning up the mud. The layers of sediment accumulate undisturbed, year after year, century after century, and when the scientists cored into the bottom of the largest pool, they found an unbroken 1,200-year record of geological events, including tsunamis, flash floods, and earthquakes, all preserved in perfect layers. And despite the toxic, oxygen-free environment, the pools were not entirely lifeless. Extremophile microbes thrived in the brine itself. Organisms adapted to conditions that would kill virtually everything else. At the edges of the pools, fish, shrimp, and eels had learned to hunt along the boundary, lurking at the shoreline of the underwater lake and waiting for smaller creatures to drift too close to the brine. When something stumbled into the pool and was stunned by the toxic water, the predators moved in to feed. As Perkis put it, the brine is devoid of oxygen, so any animal that strays into it is immediately stunned or killed, and the predators that lurk near the brine feed on the unlucky. An underwater lake at the bottom of the ocean, with predators patrolling its shores. If you wrote this into a movie, nobody would believe it, but it is real, and it is down there right now. The deep ocean is not just strange to look at, it is strange to listen to. In 1997, researchers at NOAA's Pacific Marine Environmental Laboratory were listening to the ocean. Their tool of choice was a network of hydrophones, underwater microphones, spread across thousands of miles of the Pacific. These hydrophones had originally been part of a Cold War-era surveillance system called SOSUS, the Sound Surveillance System, designed by the United States Navy to detect Soviet submarines. After the Cold War ended, NOAA gained access to the network, and scientists began using it for a completely different purpose, listening for underwater volcanic eruptions, earthquakes, and ice movement. What they heard instead was something nobody could explain. In the summer of 1997, the hydrophones recorded an ultra-low frequency sound of extraordinary power. It rose rapidly in frequency over roughly 1 minute, and it was so loud that sensors detected it more than 3,219 kilometers apart, nearly 2,000 miles. The source was triangulated to a remote point in the South Pacific Ocean, roughly 50 degrees south latitude and 100 degrees west longitude, west of the southern tip of South America. The researchers at NOAA gave it a name. They called it the bloop. When the sound was sped up 16 times for human ears to hear, it sounded like a water droplet, a brief descending plop, which is where the name came from. At its original frequency, far below the range of human hearing, it was something else entirely. It was one of the loudest underwater sounds ever recorded. The bloop immediately captured the public imagination. It was louder than any known animal call, louder than a blue whale, the largest creature on the planet. If the sound had been biological in origin, the animal producing it would have needed to be several times larger than any creature ever documented. Speculation erupted that it was the call of an unknown deep-sea leviathan, a creature so massive that science had never come close to discovering it. Internet forums exploded with theories, and websites catalogued the sound alongside other unexplained ocean phenomena. The fact that the sound originated near Point Nemo, the most remote location on Earth, and the spot in the ocean furthest from any landmass in every direction, only added to the mystique, and by pure coincidence, Point Nemo also happens to sit near the coordinates of the fictional underwater city of Raleigh from the horror stories of H.P. Lovecraft, a detail that the internet seized upon with enthusiasm. For years, the bloop was one of the great unsolved mysteries of the ocean. NOAA scientist Christopher Fox told CNN in 2001 that he believed the sound was ice calving in Antarctica, but many researchers were less sure. The audio profile of the bloop, with its rapid variation in frequency, did resemble sounds produced by living creatures, and the question was whether any living creature could possibly be that loud. Starting in 2005, NOAA deployed additional hydrophones closer to Antarctica, specifically in the Bransfield Strait and the Drake Passage. Over the next several years, researchers recorded tens of thousands of sounds, with spectral patterns nearly identical to the bloop, and they were coming from glaciers, massive sheets of ice cracking, fracturing, and carving into the sea. By 2012, NOAA seismologist Robert Zayak and his team confirmed it. The bloop was the sound of an icequake, a massive Antarctic iceberg cracking and breaking apart. Tracking of iceberg A53A, as it disintegrated near South Georgia Island in 2008, provided particularly strong supporting evidence. Zayak explained it simply, saying that each year there are tens of thousands of what they call icequakes, created by the cracking and melting of sea ice and ice carving off glaciers into the ocean, and that these signals are very similar in character to the bloop. The mystery was solved, but the ocean was not done making strange noises. The bloop was only one of several unidentified sounds recorded by NOAA's hydrophone arrays in the late 1990s. On March 1st, 1999, the network picked up a sound that lasted 2 minutes and 43 seconds, something that sounded like someone cooing or moaning, and it was recorded across the equatorial Pacific. Scientists named it Julia, and the leading explanation is that it was the sound of a large iceberg running aground on the seafloor near Antarctica. In May of 1997, around the same time the bloop was detected, a different sound descended in frequency over approximately 7 minutes. It sounded like something large was slowing down, so they called it slow down, and the most widely accepted explanation is that it was an iceberg scraping across the ocean floor. Another sound from the same period, detected on March 5th, 1997, produced a steady, constant hum. It was named train because it resembled the sound of a train rolling in the distance, and the leading theory is that it was caused by a large iceberg dragging its keel along the seafloor. Upsweep is different from the rest. First detected in August of 1991, it is a long, narrow band sound that rises in frequency and repeats with a seasonal pattern. It has been detected continuously for over 3 decades and is still being heard today. Unlike the others, upsweep has not been definitively explained, and the leading hypothesis is that it relates to undersea volcanic activity, possibly magma interacting with seawater somewhere in the South Pacific, but its exact origin remains unconfirmed. In July of 1997, sensors picked up a brief whistle of unknown origin, detected by only a single hydrophone, which meant it could not be triangulated. It was recorded, catalogued, and remains unexplained. What all of these sounds have in common is that they were captured by a system originally built to listen for enemy submarines, and instead of submarines, it found a world of natural sounds that scientists are still working to fully understand. The ocean, it turns out, is anything but silent, but the deep ocean holds more than strange sounds and bizarre creatures. It holds history, and in some cases, that history has been waiting in the darkness for decades, preserved in the cold and the pressure, until someone finally came to find it. The most famous example is the Titanic. On the night of April the 14th, 1912, the RMS Titanic, the largest ship afloat at the time, struck an iceberg in the North Atlantic during its maiden voyage from Southampton to New York City. Within 2 hours and 40 minutes, it sank, More than 1,500 people died, making it one of the deadliest peacetime maritime disasters in history. The wreck lay undiscovered for 73 years. Multiple expeditions tried and failed to find it. The ocean in that area of the North Atlantic runs roughly 12,500 feet deep, more than 2 miles, and the technology to search such a vast area at that depth simply did not exist until the early 1980s. What the public did not know was that the expedition which finally found the Titanic was not what it appeared to be. Robert Ballard, the oceanographer who discovered the wreck, was not just a scientist at the Woods Hole Oceanographic Institution. He was also a commander in the United States Navy, and the funding for his expedition came not from a university or a scientific foundation, but from the United States military. The Navy had a problem. 2 of its nuclear-powered submarines had sunk in the Atlantic Ocean during the 1960s. The USS Thresher went down in April of 1963 during deep diving tests about 300 miles off the coast of New England, taking 129 men with it, becoming the first nuclear submarine ever lost. The USS Scorpion disappeared in May of 1968, with 99 crew members aboard, somewhere in the Atlantic, between the Azores and Norfolk, Virginia. Both submarines carried nuclear reactors, and the Scorpion also carried nuclear-armed torpedoes. For the Navy, these were not just tragedies but potential environmental and security disasters. The Navy wanted to know what had happened to the reactors. Were they intact? Were they leaking radioactive material into the ocean? Was there any evidence that the Scorpion had been attacked by the Soviets? And was there any risk that sensitive technology could be recovered by a foreign power? The Navy funded the development of Ballard's deep-sea imaging system, a towed camera sled called Argo, for the express purpose of surveying the wrecks of these 2 submarines. Argo could be towed behind a ship on a long cable and stream live video from the seafloor back to the vessel, a capability that did not exist before Ballard built it. But Ballard saw an opportunity and asked the Navy if, after completing the submarine surveys, he could use whatever time remained to search for the Titanic. The Navy agreed with one condition. The submarine mission came first. The Titanic search was secondary, and the true purpose of the expedition was to remain classified. Ballard and his team surveyed the Thresher and the Scorpion. They confirmed that the nuclear reactors on both submarines had shut down safely and were not leaking. They documented the debris fields surrounding both wrecks, noting how the wreckage had spread across the ocean floor in long trails. That observation turned out to be the key to finding the Titanic. When the submarine surveys were complete, Ballard had just 12 days left on the expedition. Rather than searching for the Titanic's hull, which would be an incredibly small target at that depth, Ballard decided to search for its debris field instead. He had seen how the submarine wreckage scattered across the seafloor in a long trail, spread by currents as it sank, and the Titanic, being far larger than a submarine, would have an even longer debris trail. That trail would be a much bigger target than the ship itself. At 12:48 in the morning, on September the 1st, 1985, aboard the research vessel Knorr, a member of Ballard's team spotted something on the video feed from Argo. A large, circular object was sitting on the seafloor. The control room went quiet. They compared it to historical photographs, and it was one of the Titanic's boilers, a massive iron cylinder used to power the ship's engines. The same kind of boiler that had been photographed and documented during the Titanic's construction in Belfast. The room erupted. After 73 years, someone had finally found it. But the celebration did not last long. Someone on the team checked the time. It was almost 2 in the morning, approaching the same hour that the Titanic had slipped beneath the waves in 1912. The mood shifted, and several members of the team went up to the deck and held an impromptu moment of silence for the more than 1,500 people who had died at that spot. The Titanic lay in two main pieces at a depth of roughly 12,500 feet, about 370 miles southeast of Newfoundland. The bow section was largely intact, sitting upright on the seafloor, still recognizable as the front of a great ocean liner. The stern was badly damaged and had broken apart on its way to the bottom, its hull plates twisted and mangled by the force of implosion as compartments collapsed under the pressure of the descent. Between them stretched a debris field more than half a mile long, littered with thousands of artifacts, including plates, bottles, shoes, luggage, and personal belongings, scattered across the ocean floor like the remnants of a civilization. Ballard returned the following year, in 1986, with the submersible Alvin and a small remotely operated vehicle called Jason Jr. Jason Jr. was tiny, about the size of a riding lawnmower, tethered to Alvin by a cable, and it could be steered through openings in the wreck that were too small or too dangerous for Alvin to enter. The images it captured were haunting. The Grand Staircase, one of the Titanic's most famous features, had been destroyed by the water, but the opening where it stood was still visible. Chandeliers still hung in some of the first-class areas. China plates were stacked neatly on the seafloor, still arranged as if set for dinner. Pairs of shoes lay side by side in the mud, marking the places where bodies had once rested before being consumed by the deep-sea environment. Rust formations called rusticles, created by iron-eating bacteria, hung from the hull like stalactites, slowly consuming the ship. The discovery made headlines around the world, but the true story behind it, the secret Navy mission, the classified submarine surveys, the 12-day window, none of that became public until decades later, when the information was finally declassified. Ballard later told CNN that they did not want the world to know that, so he had to have a cover story. He added that people were so focused on the legend of the Titanic that they never connected the dots. The Titanic lies at 12,500 feet, and that is deep, but it is not even close to the deepest shipwreck ever discovered. That record belongs to another warship, a much smaller one, from a very different kind of battle. The USS Samuel B. Roberts was a John C. Butler-class destroyer escort, just 306 feet long. She was commissioned in April of 1944 and sunk just 6 months later. Her nickname was the Sammy B, and the story of how she ended up at the bottom of the Philippine Sea is one of the most extraordinary tales of courage in the history of the United States Navy. On October the 25th, 1944, during the Battle of Leyte Gulf in the Philippines, a small group of American escort carriers and their screen of destroyers and destroyer escorts found themselves in an impossible situation. They were part of a unit designated Taffy 3, and due to a catastrophic breakdown in communications, they were the only American warships standing between the Japanese center force, a fleet of 23 heavily armed battleships and cruisers under Vice Admiral Takeo Kurita, and the virtually defenseless American invasion fleet at Leyte. Among the Japanese ships was the Yamato, the largest battleship ever constructed. Taffy 3 had no battleships and no heavy cruisers, just escort carriers, 3 destroyers, and 4 destroyer escorts. They were outgunned in every conceivable way, with the Japanese force carrying 60 times the firepower of the American screening force. It should have been a massacre, but the American ships attacked anyway. Laying smoke screens and charging through a hail of incoming shells, the destroyers and destroyer escorts of Taffy 3 threw themselves at the Japanese fleet. The escort carriers launched every aircraft they had, many armed with nothing more than depth charges and machine guns, because they had not been loaded for an anti-ship engagement. The Sammy B, carrying fewer than half the guns and a third the torpedoes of a full-size destroyer, charged directly at the Japanese fleet. Her captain, Lieutenant Commander Robert W. Copeland, reportedly told his crew over the intercom that this was going to be a fight against overwhelming odds from which survival could not be expected. The ship closed to near point-blank range, with the Japanese heavy cruiser Chikuma and opened fire, inflicting considerable damage. She also attacked with torpedoes. For 2 hours, the Sami B fought warships 10 times her size until she was struck by shells from the Yamato itself. The ship was torn open, her engine room flooded, and her guns ran out of ammunition. At one of her 5-inch gun mounts, gunner's mate 3rd Class Paul Henry Carr continued to try to load and fire shells even after the gun had been destroyed and he was mortally wounded. When rescuers found him, he was still clutching a shell, trying to load it into the broken breech. The Sami B went down. Of her 224 crew members, 89 were killed. The survivors spent nearly 3 days in the water, enduring shark attacks and exposure before rescue came. The ship earned the description that would follow it through history: the destroyer escort that fought like a battleship. For 78 years, the Sami B lay somewhere on the floor of the Philippine Sea, and nobody knew exactly where. In June of 2022, Victor Vescovo returned to the deep, using the same DSV limiting factor that had carried him to the bottom of Challenger Deep, and working with French sonar specialist Jeremy Morizet. Vescovo led a team from Caladan Oceanic and EOS expeditions on a series of 6 dives over 8 days. Historical records of the wreck's location had proven inaccurate, so the team relied on archival research, advanced bathymetric mapping, and a custom-built side-scan sonar system capable of operating at full ocean depth. On June the 22nd, 2022, they found her. The Sami B was resting on a slope in 2 pieces, about 10 meters apart. Her bow appeared to have hit the seafloor with considerable force, causing some buckling. The torpedo launcher was visible, and the aft gun turret, where Paul Henry Carr made his last stand, was still recognizable. She lay at a depth, initially reported as 6,895 meters, roughly 22,621 feet. Subsequent calibration by Guinness World Records revised the figure slightly to 6,865 meters, or 22,523 feet. Either way, it made the Sami B the deepest shipwreck ever discovered, surpassing the USS Johnston, another ship sunk in the same battle, which Vescovo had found the previous year at a depth of 21,180 feet. 4 miles below the surface, a ship that weighed barely 2,000 tons, sitting in the darkness of the Philippine Sea exactly where it settled 78 years earlier, and it was found by the same man who had eaten a tuna fish sandwich at the bottom of the Mariana Trench. The deep ocean floor is not just a graveyard for ships, it is also one of the most hotly contested pieces of real estate on the planet. Scattered across a vast stretch of the Pacific Ocean between Hawaii and Mexico lies a region called the Clarion-Clipperton Zone. It covers between 4.5 and 5.1 million square kilometers, an area roughly the size of the continental United States, and the sea floor there, at depths of 4,000 to 6,000 meters, is carpeted with potato-sized rocks called polymetallic nodules. These nodules contain manganese, nickel, cobalt, and copper, metals that are essential for manufacturing batteries, electronics, and renewable energy technologies. Estimates suggest the Clarion-Clipperton Zone alone holds more than 21 billion metric tons of these nodules, containing more cobalt, nickel, copper, and manganese than all known reserves on land combined. For mining companies, the Clarion-Clipperton Zone looks like the opportunity of the century. For marine scientists, it looks like a potential catastrophe. The most prominent company pursuing deep-sea mining is the Metals Company, formerly known as Deep Green Metals. In 2022, the company conducted a test extraction in the Clarion-Clipperton Zone, collecting roughly 3,000 tons of nodules using a converted drill ship called the Hidden Gem. In April of 2025, the company applied to NOAA for a commercial mining license covering 25,000 square kilometers of the Pacific. Their plans are ambitious, envisioning small-scale extraction by 2027 and full industrial-scale mining by 2035, targeting an estimated 363 million tons of nodules, containing roughly 80 million tons of manganese, 3.5 million tons of nickel, 3 million tons of copper, and 300,000 tons of cobalt. The governing body for international seabed mining is the International Seabed Authority, an organization established under the United Nations. It has issued 31 exploration contracts, 17 of which are specifically for nodule mining in the Clarion-Clipperton Zone, and China holds the most contracts of any single country, with 5. But there is a problem. The International Seabed Authority has been working on a comprehensive set of regulations known as the Mining Code since the early 2000s. It missed its target deadline in 2020, missed again in 2023, and as of 2025, the code is still not finalized. Opposition is growing. Between 32 and 40 countries have called for a moratorium, a pause, or an outright ban on deep-sea mining, including France, Germany, and the United Kingdom. More than 1,000 marine scientists from over 70 countries have signed a statement calling for a moratorium. Norway, which had approved seabed mining in its own waters, reversed course and halted all licensing until 2029. The reason for the opposition is simple. Scientists are only beginning to understand what lives on the floor of the Clarion-Clipperton Zone, and what they are finding is alarming. More than 5,000 new species have been discovered in the zone, many of them found nowhere else on Earth. The nodules themselves are not just rocks, but serve as habitat. Organisms attach to them, build on them, and live among them. Remove the nodules, and you remove the ecosystem. One particularly sobering study examined the site of a small experimental mining test conducted in the Clarion-Clipperton Zone in the early 1970s. Researchers had dragged equipment across a patch of seafloor and then left. And when scientists returned to the site 26 years later, they found that even the simple nematodes, microscopic worms that are among the most resilient creatures in the ocean, had not recovered. The scars from a single pass of mining equipment were still visible on the seafloor after more than a quarter century. The sediment that had been disturbed had not been replenished, and the nodules that had been removed had not regrown. In the deep ocean, where things grow and change at rates measured in centimeters per 1,000 years, a single act of disturbance can erase geological history that stretches back further than recorded human civilization. Consider what that means. The polymetallic nodules on the floor of the Clarion-Clipperton Zone grow at a rate of roughly 1 to 5 millimeters for centuries. Removing just 10 centimeters of sediment from the seafloor erases 10,000 years of geological history. These are not resources that regenerate on any human timescale. Research has also shown that the sediment plumes generated by deep-sea mining do not rise and disperse as some had predicted, but instead hug the seafloor, spreading laterally and potentially smothering organisms over a wide area. A study from MIT confirmed that these plumes could travel considerable distances along the bottom, blanketing filter, feeding organisms and suffocating creatures that depend on clean water and unobstructed sediment. The question at the center of the debate is whether the demand for the metals needed for electric car batteries and renewable energy infrastructure justifies the potential destruction of an ecosystem that has taken thousands of years to develop and that we have barely begun to understand. Proponents of deep-sea mining argue that the environmental footprint of extracting metals from the seafloor is smaller than the damage caused by terrestrial mining, which involves clearing forests, displacing communities, and contaminating rivers. They point out that the transition to clean energy requires enormous quantities of cobalt, nickel, and other metals, and that land-based sources are increasingly concentrated in countries with questionable labor practices and environmental standards. Opponents counter that we do not yet know what we will destroy. The Clarion-Clipperton Zone alone contains more than 5,000 species, most of them unknown to science before the last 2 decades. Destroying an ecosystem we have barely catalogued in order to build batteries feels, to many scientists, like burning a library to heat a room. That question does not have an easy answer, but it is one that will define the future of the deep ocean for generations to come. And the deep ocean has more to show us still. Beyond the mines and the shipwrecks and the strange sounds, phenomena exist in the deep that defy easy explanation. Massive patches of ocean glow in the dark. Geometric patterns on the seafloor are created by tiny fish. Pollution from the surface world reaches depths that no human has ever visited. The deep ocean is not just the last frontier on Earth. It is a mirror, reflecting back everything we have done to the planet, and everything we have yet to learn about it. The strangeness of the deep ocean does not stop at creatures and shipwrecks and sounds in the dark. Phenomena exist down there so bizarre, they seem to violate the laws of nature itself. Consider what happens in certain parts of the Indian Ocean and the waters near Indonesia. For centuries, sailors reported something that sounded impossible. They described nights when the entire ocean, from horizon to horizon, in every direction, began to glow. Not the brief sparkle of bioluminescent waves crashing on a beach or the flash of a disturbed jellyfish, but a steady, uniform, unbroken glow that stretched as far as the eye could see, turning the surface of the sea into what looked like a field of snow or a vast sheet of pale light. Dutch sailors called it the Winter Sea because it reminded them of a snowy plain at night. Other mariners described it as sailing across a sea of milk. Jules Verne described it in his novel 20,000 Leagues Under the Sea, writing that the whiteness was caused by the presence of myriads of infusoria, a sort of luminous little worm. The phenomenon became known as a Milky Sea. Between 1915 and 1993, 235 sightings of Milky Seas were documented, most of them concentrated in the northwestern Indian Ocean near Somalia and the Horn of Africa. In 1985, a United States naval research vessel happened to sail through one in the Arabian Sea near Socotra, and the crew collected water samples containing a bioluminescent bacterium called Vibrio havae, which they concluded was the likely source of the glow. For decades after, the broader scientific community remained skeptical because the concentration of bacteria required to produce such a massive, uniform glow was thought to be impossible in open ocean conditions. In 2005, a scientist named Stephen Miller decided to check. Miller, a researcher at what was then the Naval Research Laboratory and later at Colorado State University, went looking for satellite data from the United States Defense Meteorological Satellite Program. He found a ship report from the British merchant vessel SS Lima, which recorded sailing through a Milky Sea in the Indian Ocean in January of 1995. When Miller acquired archival satellite imagery from the same night and overlaid it with the Lima's recorded coordinates, he saw it. A vast, bright patch in the ocean, glowing steadily in the darkness. The satellite data showed a bioluminescent area of approximately 15,400 square kilometers, roughly the size of the state of Connecticut, and it glowed for 3 consecutive nights. The results were published in the Proceedings of the National Academy of Sciences in 2005. It was the first satellite confirmation of a Milky Sea. The leading hypothesis is that the glow is produced by massive colonies of Vibrio havae, which begins to emit light when it reaches a critical population density through a process called quorum sensing. When enough bacteria are present in one place, They communicate chemically and switch on their light-producing genes in unison. Trillions of bacteria glowing together across thousands of square miles of ocean. In 2019, satellite sensors detected a Milky Sea south of Java, Indonesia, that spanned more than 100,000 square kilometers, an area roughly the size of Iceland. The crew of a private yacht called the Ganesha happened to be sailing through the region, and when they learned about the satellite detection, they reached out to confirm what they had seen with their own eyes. The captain reported that the glow appeared to originate from roughly 10 meters below the surface. It was steady and uniform, and the water in the ship's wake did not glow more brightly, which meant the light was not being triggered by disturbance. It was simply on. The crew's account was published in the Proceedings of the National Academy of Sciences in 2022, making it the first time that a satellite detection of a Milky Sea had been confirmed by an eyewitness vessel in near real time. And yet we still do not fully understand why Milky Seas form, what triggers them, or what they mean for the ecosystems in which they appear. As Miller himself has noted, Milky Seas are simply marvelous expressions of our biosphere, whose significance in nature we have not yet fathomed. A patch of ocean the size of a country, glowing in the dark, visible from space, and we still do not know why. Other mysteries on the seafloor took decades to solve. In 1995, divers off the southern coast of Amami Oshima Island in the Ryukyu Islands of Japan noticed something strange on the sandy bottom at a depth of about 10 to 20 meters. Carved into the sand were elaborate geometric patterns, circular structures roughly 2 meters across, with radially aligned ridges and valleys forming intricate, symmetrical designs. They looked almost man-made, as if someone had drawn a perfect mandala on the ocean floor. Nobody could explain them. They appeared, lasted for a time, and then disappeared as the current smoothed the sand back to its original state. They were dubbed mystery circles, and for more than 15 years, they remained one of the ocean's most charming unsolved puzzles. In 2013, researchers led by Hiroshi Kawase published a study in the journal Scientific Reports that revealed the answer. The circles were being built by a tiny pufferfish, barely 10 centimeters long, roughly the size of a human hand. Males of what turned out to be a previously unknown species spent roughly 9 days constructing these elaborate structures, working from dawn until dark, using their fins and bodies to dig radial valleys from the outside inward. The fish pressed its belly against the sand and flapped its pectoral and caudal fins rapidly, carving channels into the seafloor, and over hundreds of individual passes, a geometric pattern of peaks and valleys emerged surrounding a flat central area. In the final stages, the males decorated the ridges with fragments of shell and coral and created a maze-like pattern in the central zone by flapping their anal fins along the bottom. Thousands of individual digging movements went into each circle. The fish worked methodically, starting from the outside and moving inward, adjusting angles and depths as it went, and the finished circle was remarkably symmetrical, each one slightly different from the last, reflecting the individual effort and precision of the builder. The purpose was courtship. Males built the circles to attract females, but the structure was not merely decorative. Research showed that the radial pattern channeled water currents inward toward the center, depositing fine sediment particles there and creating a calm, protected area where the female would lay her eggs. The architecture served a practical function, both advertisement and nursery. Females visited the circles, inspected them, and chose mates based at least in part on the quality of the construction. The species was formally described in 2014 by ichthyologist Keiichi Matsuura of the National Museum of Nature and Science in Tokyo and named Torquigena albomaculosus, the white-spotted pufferfish. In 2015, it was named one of the top 10 new species by the International Institute for Species Exploration, and Sir David Attenborough later described it as probably the greatest artist in nature. In 2018, researchers made another surprising discovery. Similar circles were found off the coast of Western Australia at depths of 129 to 137 meters, apparently constructed by a related but unidentified species of Torquegina, more than 5,500 kilometers from Japan. The behavior was not unique to a single species in a single location, but a strategy that pufferfish had developed independently in different parts of the world. A 10-centimeter fish building a 2-meter architectural masterpiece on the ocean floor, one grain of sand at a time, to impress a mate. The deep ocean has its own artists, and they have been at work long before we ever knew they were there. One more natural phenomenon needs mention, because it is arguably the strangest of them all. It is a waterfall underwater. Between Greenland and Iceland lies a narrow channel of ocean called the Denmark Strait, roughly 100 miles wide. At the surface, you would see nothing unusual, just typical cold Arctic waters, calm conditions, the occasional swell, and depending on the season, perhaps some ice. A ship passing through would notice nothing out of the ordinary. But beneath the surface, something extraordinary is happening, something that dwarfs every waterfall on the face of the planet. On the western side of the strait, the seafloor drops away in a massive slope, and down that slope, cold, dense water from the Greenland Sea is pouring in an endless cascade into the warmer, lighter waters of the Erminger Sea below. It is called the Denmark Strait Cataract, an underwater waterfall, and it is the largest waterfall on Earth by almost every measure. The Denmark Strait Cataract drops approximately 3,500 meters, or 11,500 feet, from the crest of the underwater ridge to the deep pool at the bottom. Angel Falls in Venezuela, the tallest waterfall on land, drops 979 meters, which means the Denmark Strait Cataract is more than 3 times that height. If you could somehow drain the ocean and stand at the bottom looking up, you would be staring at a wall of water taller than 8 Empire State Buildings stacked on top of each other. The column of falling water is roughly 200 meters wide and 200 meters thick, descending over a horizontal distance of roughly 500 to 600 kilometers. The flow rate is almost incomprehensible. Approximately 175 million cubic feet of water cascade over this underwater cliff every single second, roughly 2,000 times the flow rate of Niagara Falls. Some estimates suggest the total water transport is equivalent to 20 to 40 times the combined flow of every river that empties into the Atlantic Ocean. The waterfall exists because of a difference in density. Water flowing south from the Nordic seas is extremely cold and exceptionally salty, because as Arctic water freezes into ice, the salt is left behind in the remaining liquid, making it denser and heavier. When this dense water meets the warmer, lighter water of the Erminger Sea, it does not mix but sinks, and as it sinks over the underwater ridge in the Denmark Strait, it creates a massive, slow, moving cascade that falls all the way to the bottom of the slope, roughly 3,000 meters below. The water does not fall quickly. Unlike Niagara Falls, where water plunges at roughly 100 feet per second, the Denmark Strait Cataract flows at just 1.6 feet per second, barely half a meter. It is slow, but it is relentless, and the sheer volume of water involved is staggering. From the surface, you would never know it was there. No mist, no roar, no rainbow. As one researcher put it, at the surface, you just have typical sunny Arctic conditions. But beneath the waves, the largest waterfall on the planet flows continuously, day and night, year after year. It is a critical part of the global thermohaline circulation, the conveyor belt of ocean currents that distributes heat around the planet and regulates climate systems that affect every person on Earth. An invisible waterfall, 3 times taller than the tallest waterfall on land, carrying 2,000 times more water than Niagara, hidden beneath the surface of a strait that most people have never heard of. That is the deep ocean in a single image. But not everything that reaches the deep ocean floor is natural, and not everything down there is beautiful. Some of the most troubling discoveries in the deep ocean have nothing to do with strange creatures or ancient wrecks. They have to do with us. Victor Vescovo found a plastic bag and candy wrappers at the bottom of the Mariana Trench in 2019, at nearly 11,000 meters below the surface. That discovery was shocking, but it was not an isolated incident. Scientists had been documenting the spread of human pollution into the deepest parts of the ocean for years, and the evidence keeps getting worse with every expedition that goes looking for it. Microplastics, tiny fragments of plastic less than 5 millimeters across, have now been found in virtually every marine environment on the planet, from Arctic sea ice to Antarctic sediment, from coral reefs to the open ocean surface, from the stomachs of whales to the bodies of microscopic plankton. But the most disturbing findings have come from the Hadal trenches, the deepest places on Earth. Chinese research expeditions in 2020 and 2021 retrieved water and sediment samples from the Mariana Trench that contained microplastic fibers, and these were not floating on the surface or drifting through the water column. They were embedded in the sediment at the very bottom of the ocean, 7 miles below the waves, in a place where no human had set foot until 1960, and where the pressure exceeds 1,000 times that at the surface. Laboratory analysis of amphipods, the small crustaceans that are among the most common animals in the deep trenches, revealed something even more alarming. Their bodies contain traces of persistent organic pollutants, industrial chemicals banned decades earlier. Substances like PCBs, which were widely used in electrical equipment and building materials, and PBDEs, used as flame retardants in furniture and electronics, were still present in the tissues of animals living at the most remote point on the planet. These chemicals were manufactured in factories, used in homes and offices, and eventually washed into rivers and oceans, where they began their long, slow descent to the bottom. The explanation lies in how the deep ocean works. Organic matter and particles sink slowly from the surface, carrying pollutants with them. Dead organisms, fecal pellets, and what scientists call marine snow, the constant gentle rain of organic debris falling through the water column like an underwater blizzard, all carry contaminants downward over weeks and months. Water at the bottom of the ocean moves extraordinarily slowly, with currents in the deep trenches that are sluggish, sometimes barely perceptible, measured in centimeters per year rather than meters per second. Once something reaches the bottom, it stays there, and researchers believe that contaminants sinking into the deepest parts of the ocean could remain trapped for thousands of years, accumulating in the sediment and working their way up through the food chain. We have polluted the one place on Earth that no human being had visited until 1960. We have left our chemical signature in a place that takes nearly 5 hours to reach in a submersible, and that crushes everything not specifically engineered to survive there. The Mariana Trench is not remote enough to escape us. The Hadal Zone is not deep enough. Nowhere on this planet is. The ocean absorbs our waste the way it absorbs everything else, silently and invisibly. But the evidence accumulates in the sediment and in the bodies of the creatures that live there, and the deep ocean remembers what we would prefer to forget. So, where does that leave us? We began this documentary with a simple number. Less than 1,000% of the deep ocean has been visually observed by human beings, and look at what we have found in that tiny fraction. Underwater lakes that kill anything that enters them, patrolled by predators that have learned to feed on the unlucky. Entire ecosystems powered not by the sun, but by the chemistry of the Earth itself, thriving in total darkness around volcanic vents, blasting superheated water at 662 degrees. Creatures with transparent skulls and parasitic mates that dissolve into their partners. Fish that build geometric temples on the sand. Squid with eyes the size of dinner plates that haunted human mythology for 1,000 years before we filmed one alive. The largest waterfall on the planet, 3 times taller than Angel Falls, flowing continuously beneath the waves without a sound. Patches of ocean larger than countries glowing in the dark, powered by bacteria communicating through chemistry we still do not fully understand. A ship that fought like a battleship, 4 miles below the surface, exactly where it settled 78 years earlier. The most famous shipwreck in history, discovered by accident during a classified military operation. Sounds from the deep that took 15 years to explain, and at least one that still has not been. Plastic bags at the deepest point on the planet. Industrial chemicals banned half a century ago in the tissues of creatures we did not know existed, and life thriving in places where science once told us nothing could survive. All of this in less than 1,000th of 1%. Here is a timeline of the discoveries we have covered, to put the pace of exploration in perspective. 1872 to 1876. HMS Challenger circumnavigates the globe, conducting the first systematic study of the deep ocean. More than 4,700 new species are catalogued, and oceanography is born as a science. 1930 to 1934. William Beebe and Otis Barton descend in the bathysphere off Bermuda, reaching 3,028 feet, becoming the first human beings to observe the deep sea with their own eyes. Gloria Hollister documents every word they say. 1960, Jacques Piccard and Don Walsh descend to the bottom of Challenger, deep in the bathyscaphe Trieste, reaching 10,916 meters. Nobody returns to the bottom for over 50 years. 1977. Scientists aboard the submersible Alvin discover hydrothermal vents on the Galapagos Rift, along with an entire ecosystem powered by chemosynthesis, one of the most important biological discoveries of the 20th century. They preserve specimens in Russian vodka because they run out of formaldehyde. 1979. Black smokers are discovered on the East Pacific Rise, blasting 350-degree water from chimney-like structures on the seafloor. 1985. Robert Ballard discovers the RMS Titanic at roughly 12,500 feet during a classified Navy mission to survey 2 lost nuclear submarines. He had 12 days. 1991. The sound known as upsweep is first detected by NOAA's hydrophone network. It is still being heard today and remains unexplained. 1995. Divers in Japan discover the first mystery circles on the seafloor near Amami Oshima Island. The creator will not be identified for 18 years. 1997. NOAA records the bloop and several other unidentified ocean sounds. The bloop is eventually traced to an Antarctic icequake. 2004. Japanese researchers Tsunemi Kubodera and Kyoichi Mori photograph a live giant squid in its natural habitat for the first time, off the Ogasawara Islands at 900 meters. 2005. A Milky Sea covering 15,400 square kilometers is confirmed by satellite imagery for the first time in the Indian Ocean. 2012. James Cameron becomes the first person to complete a solo dive to Challenger Deep. The giant squid is filmed alive in the deep ocean for the first time by a Japanese and American team. 2013. Researchers reveal that the mystery circles on the seafloor near Japan are built by a tiny pufferfish to attract mates. 2019. Victor Vescovo reaches a record depth of 10,928 meters in Challenger Deep. He finds a plastic bag and candy wrappers at the bottom. 2020. Catherine Sullivan becomes the first woman to visit Challenger Deep. The Chinese submersible Fendouzha discovers the deepest chemosynthetic life ever found. At more than 31,000 feet, the Neom brine pools are discovered in the Gulf of Aqaba. 2022. The USS Samuel B. Roberts is found at 6,865 meters, becoming the deepest shipwreck ever discovered. The first Milky Sea is confirmed simultaneously by satellite and eyewitness in near real time. 2023. The deepest fish ever recorded, a snailfish, is filmed at more than 8,230 meters in the Ogasawara Trench. 2025. More than 30 new species are discovered in the Southern Ocean. More than 40 are found in the deep waters off Argentina. The Metals Company applies for the first commercial deep-sea mining license in the Pacific. The debate over the future of the ocean floor intensifies. That is a century and a half of discovery, and we have barely started. Think about what the scientists aboard the Challenger must have felt in 1872, pulling up creatures from the deep that nobody had ever seen before, realizing for the first time that the ocean floor was not a barren wasteland. Think about Beebe and Barton in the bathysphere, dropping into blackness through a window the size of a dinner plate, watching creatures appear out of the void that they could not even name. Think about Picard and Walsh, sitting in a steel sphere 7 feet wide at the bottom of the world, watching a flatfish swim slowly across the sediment in a place where no living creature was expected to exist. Think about Jack Corliss on that first dive to the Galapagos Rift in 1977, looking through the viewport of Alvin and seeing a garden of giant clams and tube worms where textbooks said there should be nothing. Think about the team on the Nore in 1985, staring at a grainy black and white video feed at 2 in the morning, realizing they were looking at a boiler from the Titanic. Think about Vescovo at the bottom of Challenger Deep, eating a sandwich and looking out the viewport at the most remote spot on the planet, only to see a plastic bag drifting past. Every one of those moments changed what we knew about the deep ocean, and every one of them came as a surprise. Robert Ballard once said that the greatest age of exploration is not behind us, but ahead of us, and it is not in outer space, but in inner space, in the deep ocean, right here on our own planet. He was right. Every time we send a submersible into the deep, we find something we did not expect. Every time we turn on a camera at the bottom of the ocean, we see something that has never been seen before. Every time we lower a net or a sampling device into a trench, we pull up organisms that science has never documented. The pattern has held for 150 years, and there is no sign it is slowing down. The deep ocean is not a wasteland, not a void, and not the empty, lifeless abyss that scientists believed it was before HMS Challenger proved them wrong in 1876. It is the largest living space on Earth, and it is full of things we do not yet understand. Things that glow, things that build, things that survive in conditions that should make life impossible, things that challenge our assumptions about what life needs, where it can exist, and how strange it can become. We have learned more about the deep ocean in the last 50 years than in all of prior human history, and yet the number remains. 90% unexplored. Less than 1,000% visually observed by human eyes. Sylvia Earle, the oceanographer who has spent more time underwater than perhaps any human being alive, has spent decades trying to convince the world that the ocean is not just a resource to be exploited. She calls it the blue heart of the planet and says we should take care of it as if our lives depend on it, because they do. The ocean produces more than half of the oxygen we breathe. It absorbs roughly a quarter of the carbon dioxide we produce, and more than 90% of the excess heat generated by greenhouse gas emissions. It regulates our climate, drives our weather, and feeds billions of people. The deep ocean, the part we cannot see and have barely visited, is the engine that keeps all of it running. The thermohaline circulation, the nutrient cycling, the carbon sequestration, and the biological processes that sustain the entire marine food web all depend on the deep. Without the deep ocean, the surface ocean does not function. Without the surface ocean, the atmosphere does not function. Without the atmosphere, we do not function. We are making decisions right now about mining, about pollution, about climate that will affect the deep ocean for centuries. And we are making those decisions with less than 1% of the information we need. Less than 1,000th of 1%. That is how much we have seen. The deep ocean has been here far longer than we have. It will be here long after we are gone, and it is still full of secrets that we have not even begun to imagine. Think about that number. Think about everything we have shown you in this documentary. The creatures, the vents, the wrecks, the sounds, the glowing seas, the underwater waterfalls, the toxic lakes, the pollution, the battles fought 4 miles beneath the surface. All of that came from less than 1,000th of 1%. Now imagine what is waiting in the rest.